They say that Z is a complex number like this, and then they also tell you that Z is a purely imaginary number. That means if we write Z is equal to the real part plus the imaginary part, usually we use A and B, but because they use A already, so I avoid to use it. This is the real part, while this one, the K, is the imaginary part. And the question say purely imaginary. That means they try to tell you that the real part is basically 0. And we don't know many things about the imaginary part. So that is the information we are going to use. But now the problem is this is not yet separated to the real part and imaginary part. The operation to separate it is exactly the same as rationalizing a fraction. So we write down Z is equal to 4i power 6 plus 2ai over 1 minus I. I power 6 we can downgrade to the lower power by using the facts we know about I, imaginary number. So every I power 4 is back to normal, give you plus 1. So we try to isolate it. I power 6, that means I power 2 times I power 4. And then I power 2, we can replace it by negative 1. I power 4, we replace it by positive 1. So we have negative 4 plus 2ai here over 1 minus I. We simplified our target, and then we are going to remove the imaginary part from the denominator. So it seems like rationalizing a number. The method is use the common identities. If we find 1 minus I, then we can multiply 1 plus I in order to get both square term here. That's how we remove the I, because I square can change to negative 1. So therefore, we make the decision, the numerator, denominator, the whole thing, we are going to times 1 plus I. We are not going to multiply the same thing, because the same thing will still give us I here in the middle term. And then we just follow our step, our decision. The denominator, we will have something square minus something square. 1 square minus I square, and that's why this will become real number so that we can separate it. But above, we can just follow our step. So maybe I separate the red bracket. We have 1 something, we have positive I something. The multiply is negative 4 plus 2ai. The rest are just following the step. We have 1 minus negative 1, I square is negative 1. And then we have negative 4, positive 2ai, negative 4i, and then plus 2ai square. So we have another I square, we are going to replace it by negative 1. Negative 1 times 2a, we get negative 2a. To separate without I with I, we are going to look negative 4 and negative 2a we write first. Negative 4, negative 2a, and then plus 2ai minus 4i. Divide by 2. So every term we separate and then divide by 2, we have negative 2 minus a. We have positive ai minus 2i. We don't know anything about this part, but we know the real part here must be 0 because of the expression purely imaginary here. So therefore, we know the real part negative 2 minus a equal to 0, which means a is equal to negative 2. The answer is A.